For lesson 1, we're doing general probability, and just generally, what would be the probability of certain events occurring. Like in lesson 1 for number 5, the directions are asking us to choose whether each event would be impossible, unlikely, equally likely, likely, or certain. Well, for the spinner to land on green, that would be likely since most of the spinner is green. For number 6, the spinner on the right lands on blue. There's no blue on the spinner, so that would be impossible. Look at one like number 7, that you would guess one winning number between 1 and 500. Since there's only one winning number from 1 to 500 with so many choices, it would be unlikely that you would guess the winning number. For a problem like number 9, they tell us that the chance of Jill's missing a free throw is 3/10. And they want us to write that 3/10 as a decimal and as a percent. And when you change a decimal to a percent and you move the decimal over to the right 2 times, you would get 30%. Number 10, the question's asking, is it less likely that you choose a pecan or a cashew from the bag? And if you look at the percentage chance of picking each one, the pecan has a 20% chance of being chosen and the cashew has a 15% chance. The one that was less was the cashew at 15%. Lesson 2, we're finding experimental probability, which is the probability based on an experiment or an event that has already occurred. For number 1, they want us to give the outcome in the sample space. Well, the outcome is what was the result of spinning the spinner. The result was a 6. The sample space are all of the numbers that you could have gotten when you spun the spinner, which would be 2, 4, 6, and 8. For number 2, we're using the frequency table based on Josh's favorite baseball player's hits in 15 games. And it says find the experimental probability that his player will get 1 hit in a game. Using the table, if we look up, he had 1 hit in 8 out of the 15 games, so that would be the probability, 8 out of 15. Number 3, based on Josh's results, is the player more likely to get 2 hits in a game or no hits in a game? Well, if we look, he gets 2 hits in 2 of his games, he gets no hits in 4 of his games. So it's more likely that he's going to get no hits in a game. The second question asks, how many hits will this player most likely get in a game? Looking at the frequency, the highest frequency was 1 hit. Lesson 3 is on theoretical probability, which is what should happen, what should theoretically happen. It is not what has happened as experimental probability is based. For example, in number 1, they want to know what is the probability that a fair coin will land tails up. Well, there's 1 tails out of the 2 possible outcomes on a coin, so that would be 1 out of 2. For number 2, what is the probability of randomly choosing a vowel from the letters A, B, C, D, and E? Well, there are 2 vowels out of the 5 letters listed, so that would be a 2 out of 5 probability. Number 3, we want to know what is the probability that the spinner will not land on blue. We're told that the probability that it will is 26%. So to get the probability that it won't, we would have to subtract 26% from 100%, and that would give us 74%. Number 4, if you have an unfair number cube and the probability of rolling a 2 is 7/10, and when they want to know what is the probability that you will not roll a 2, you'll have to subtract 7/10 from 1 whole to get 3/10. If you have probability problems like numbers 10 through 17, where you're using a standard number cube, they abbreviate the question. The capital P in number 10 would stand for what is the probability, and the 4 in parentheses would stand for getting a 4. So that would mean what's the probability of rolling a 4? There's 1 4 on a number cube out of 6 possible outcomes. If we look at number 12, probability of spinning a 1, 2, or 3. Well, there's 1, 2, 1, there's 1, 1, 1, 2, and 1, 3 on a number cube. So that's 3 of the numbers out of the 6 numbers on the cube. That probability can be reduced to 1 out of 2. If we have one like number 13, the probability of getting a number greater than 0. Well, all 6 numbers on the number cube are greater than 0, so that probability would be 1. We have one like number 17 where we're asked what is the probability of getting a negative number. Well, there are no negative numbers on the number cube, so that's impossible, and that probability would be 0.